Hello there, judgers. Today, we'll be discussing an equation of hyperbola with center at the origin. So, for the first example, we have y squared over 16 minus x squared over 9 is equal to 1. So, let us rewrite the example. So, we have y squared over 16 minus x squared over 9 is equal to 1. So, in graphing this one, we need to sketch the foci, the vertices, also the co-vertices, and the asymptotes. So let us first identify the transverse axis or our major axis. So for the transverse axis, so because y squared is positive, therefore we'll be calling this as tie. Transverse axis vertical. So the center is located at point 0, 0. So we all know that whichever is positive, so that becomes the a squared. So we have a squared is equal to 16. Therefore, solving for the value of a, we have plus minus 4. We also have b squared, which is 9. We have b is equal to plus minus 3. So in solving for c squared, we all know that c squared is the largest among the three variables. Therefore, c squared is equal to the sum of a squared and b squared. Substituting this into our equation, we will be having 16 plus 9. Therefore, c squared is equal to 25 and c is equal to plus minus 5. Okay, so let us solve for the equation of the asymptote. So, for the equation of the asymptotes, because we all know that we have a transverse axis vertical, the equation of the asymptotes would be y is equal to plus minus a over bx. Therefore, y is equal to plus minus, what is our a? Our a is 4 and our b is 3. Therefore, this is now the equation of our asymptotes. So, let us solve for the coordinates of the vertices, the foci, and the co-vertices. So, for the vertices, so we have transverse axis vertical. Therefore, we will be adding and subtracting from the y ordinates. So we have 0 and then 0 plus minus a. Therefore, we have v1, which is 0, and then 0 plus minus 4. We have v1 as 0 and 4, and we also have v2 as 0 and negative 4. For the foci, we have 0 and 0 plus minus c. Vertices and foci are collinear. Therefore, we could find the vertices and foci on the y-axis. So, f should be 0 and then 0 plus minus 5. Therefore, f1 should be located at 0 and 5, and f2 should be located at 0 and negative 5. So let's now have the co-vertices W. So the co-vertices should be the opposite axis of the vertices and the foci. Therefore, we will be adding and subtracting values from the x coordinates. So we'll be having 0 plus minus b and then 0. Therefore, W should be located at 0 plus minus, what is the value of b? We have 3 and then 0. W1 should be located at 3 and 0. And W2 should be located at negative 3 and 0. So let us now try to graph these points and the hyperbola. So let us try to graph. So we all know that our hyperbola would be opening up and down, and it looks like this one. So we have the vertices. So V1 is located at 0 and 4. So 1, 2, 3, 4. So this is V1. And we also have V2, which is located at 0, negative 4. 1, 2, 3, 4. So this is our V2. So that is 0 and 4. And V2 is located at 0, negative 4. So we also have our foci located at 0 and 5. 1, 2, 3, 4, 5. So this is F1 located at 0 and 5. So we also have our F2, which is 0, negative 5, 1, 2, 3, 4, 5. So this is our F2. Points 0, negative 5. So where are the co-vertices? We have 3 and 0 and negative 3, 0. 1, 2, 3. So this is W1 located at 3 and 0. W2 located at negative 3 and 0. So this is our W2, negative 3 and 0. So the next part now is to draw an auxiliary rectangle. So auxiliary rectangle, so this is our auxiliary rectangle. It will pass through the vertices and the co-vertices. So why do we have to draw an auxiliary rectangle? So we need to draw an auxiliary rectangle in order for us to find or to locate the asymptotes. So the asymptotes are the diagonals of our auxiliary rectangle. So let us draw the diagonals. So these are the asymptotes. So we're now ready to draw the hyperbola. So the first one should be opening upward. And this is the second one. So it will get closer and closer to the asymptotes, but they will never ever meet at any point. So this is the solution. So this is now the hyperbola having an equation y squared over 16 minus x squared over 9 is equal to 1. And the asymptotes would be y is equal to 4 thirds x, and the other one is y is equal to negative 4 over 3x. Okay, so for our next example, we have 25x squared minus 16y squared is equal to 400. We are asked to graph and then find the asymptotes. So we are given a general form of the hyperbola. And in order for us to graph and to find the asymptotes, we need to transform this first into the standard equation. So in order for us to transform this into standard equation, always remember that the right side of the equation should always be equal to 1. So in order for our equation, for the right side of our equation to be equal to 1, we need to divide both sides by 400. So let us divide both sides by 400. So 25x squared over 400 will give us an answer of x squared over 16 minus 16y squared over 400 will give us an answer of y squared over 25. And the right side is 400 over 400. Therefore, that is equal to 1. So let us work on this equation. So our equation will be x squared over 16 minus y squared over 25 is equal to 1. So that is now our equation. So basing from this equation, let us first identify the transverse axis. Therefore, x squared is positive. The transverse axis is x. So we'll be having values of a squared is equal to 16. Therefore, a is equal to plus minus 4. B squared is equal to 25. Therefore, b is equal to plus minus 5. And for c squared, so c squared is equal to a squared plus b squared. Therefore, that is 25 plus 16. Therefore, c squared is equal to 41. And c is equal to square root of 41. Therefore, that is c is equal to plus minus 6.4. So for the asymptotes, we all know that this is transverse axis horizontal. We all know that this is transverse axis horizontal. Therefore, y is equal to plus minus b over ax. And y now is equal to plus minus 5 over 4x. So this will be the equation of the asymptotes. So let us locate the vertices, the foci, and the co-vertices. So the vertices, V, should be located at, so the location should be plus minus 4, 0. So because transverse axis horizontal, therefore V1 is located at 4 and 0, and V2 should be located at negative 4 and 0. So we have F. So for F, that is plus minus 6.4 6.4 and 0. So we'll be having F1 is 6.40 and F2 would be negative 6.4 and 0. So for the co-vertices, so W, so that should be 0 plus minus 5. Therefore, W1 should be W1 should be 0, positive 5, and W2 should be 0, negative 5. Okay, so those are our co-vertices. So we're now ready to graph the hyperbola. So because the transverse axis is horizontal, therefore our parabola would open to the right and to the left. Okay, so let us draw the vertices. So it is located at 4 and 0, 1, 2, 3, 4. So this is our V1. That is 4 and 0. So V2, negative 4 and 0, 1, 2, 3, 4. So this is our V2. So that is located at negative 4 and 0. We have F1. So F1 is 6.4, 1, 2, 3, 4, 5, 6. So this is our F1. So the location is 6.4 and 0. We have our F2. So 1, 2, 3, 4, 5, 6. So this is our F2. The location is negative 6.4 and 0. So we have W1 and W2, 0, 5, 0, 1, 2, 3, 4, 5. So this is W1, the location is 0 and 5. We also have W2, which is 0 and negative 5, 1, 2, 3, 4, 5. So this is our W2. The location is 0, negative 5. So let us now draw the auxiliary rectangle. So this is the auxiliary rectangle. And we're now ready to draw the asymptotes. Okay, so our hyperbola would be having a graph of this one. So those are the equation of the asymptotes. And this is now the graph of x squared over 16 minus y squared over 25 is equal to 1.